All right, example 17, we are using problems without right angles. So this one, it's asking us to find the height of there, which we can't really do unless we've got that, because then we can just use normal trigonometrical ratios to work it out. But to find that length, we'll call it x for now, we're going to need a couple of things. Now, we've got an angle opposite and we've got a side here, but to use the sine ratio, we need that angle in there. We don't know what that is, but we can work out what this angle is here, because 180 minus 51 gives us 129 degrees. So we know what that one is there, 129 degrees. Okay, so that is the 180 minus the 51 gives us 129 degrees. So that's that. Now, we also know that this is a third angle in a triangle. So the angle sum of a triangle is 180 minus 32 minus 129 degrees will give us a grand total of 19 degrees. Now, there is another way you could do that. If I get rid of this for a sec and this, these two angles here have to add up to give you 51. So you could also have done 51 minus 32 equals 19 degrees, and that will give you that angle. The main thing is we now know that that angle is 19 degrees. So I'm going to label these sides A and where's my other one? B up there. So we're using A over sine A equals B over sine B. Okay, do we know what little a is? It is x at the moment, that's our unknown. But big A is 32 degrees. Little b is 10 meters. And big B, we've just worked out, is 19 degrees. So we chuck that in. So x over sine 32 equals 10 over sine 19. We're going to rearrange that so that x is the subject. And we end up with 10 over sine 19 times sine 32. And that will give us our thing. Chuck that into the calculator as is. So 10 over sine 19, don't forget to close your bracket, times sine of 32 will give us an answer of 16.276, blah, 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 blah. And it does say to the nearest meter, but we're not going to round that yet, because all we found is we've found x here on that side there. So we now need to work out this height, but we now have a triangle that looks somewhat like that. We have that, we've got h there. We've just worked out that this is 16.276 whatever, and we have this angle is 51 degrees. So now we can actually say, well, that's theta, that is the opposite, and that is the hypotenuse. So we can now use sine of theta equals opposite over hypotenuse. Theta equals 51 degrees. The opposite equals h, and the hypotenuse equals a 16.276, blah, blah, blah. Chuck that into your calculator. So sine of 51 equals h over, I'm going to use the answer button again. We've talked about this a few times, because that way I've got the exact thing. And that means that the answer from the previous question times sine 51 equals h. So we'll chuck that in. So answer times sine 51, close my bracket, equals, and I get h equals 12.649, blah, blah, blah. But it does say to the nearest meter, so h equals 13 meters. And we're done.